Today's lesson comes from section 2.4, day 1. Our objective is to solve multi-step equations with variables on both sides. So there's some steps that you're going to want to follow in order to make sure that you're doing this process correctly. Okay, the first thing that you're going to do always is you're going to simplify by distributing. So if you see parentheses on either side of the equal sign, you're going to want to make sure that you distribute. Okay, the second thing is you're going to collect like terms on either side of the equal sign. So collect like terms on the left side, collect like terms on the right side. Then the third thing you're going to do is you're going to move all of your variables to the left side of the equation. And then step 4 is to move all of your constants to the right. And in case you're not sure what a constant is, that would be our numbers like 2, -5, 7. Those would be examples of constants. And then last but not least, you're going to solve. Okay, so we're going to go through, I'm going to work through 4 examples, and then I'm actually going to give you guys 4 examples to do on your own. Okay, so the first example is -2 times 3x, or sorry, times 3 plus x, let's do, plus 7x equals 4 minus parentheses 2x plus 1. Okay, so according to step 1, the first thing I'm going to want to do is so on both sides of the equal sign, I'm going to distribute. So -2 times 3 is -6. -2 times positive x is -2x. And I'm done distributing, so I bring down this positive 7x. Equals, on the right-hand side, I bring down the 4. In front of the parentheses is a 1, so I'm going to distribute -1 to the 2x, that's -2x. Distribute -1 to the positive 1, that's -1. Alright, there are no parentheses anymore, so I'm going to collect like terms. On the left side, I have -2x plus 7x, so that's 5x. And then I'm going to bring down that -6. Equals, on the right side, I have 4 minus 1 is 3, and I'm going to bring down that -2x. Alright, moving on to step 3. Step 3 says I'm going to move all of my variables to the left side of the equation. So I'm going to move this -2x off of the right side by adding it. So I'm going to add 2x to both sides. And that gives me 7x minus 6 equals 3. And then I want to go ahead and move my constants to the right. So in order to move this -6 here, I'm going to have to add it to get it off the right side, or the left side. Okay, so I add 6 to both sides. And so then I have 7x on the left side equals 9 on the right side. And last step is to solve. So to solve this, I divide both sides by 7. And x equals 9 over 7. Okay. And just like the other problems, you could go ahead and plug this number back in or substitute back into the original problem and check your work. But to save time right now, we're going to move on to example 2. I'll let you guys do that on your own. Okay, so 3x minus parentheses 5x minus 4 equals -8x plus 2 squared minus 2x. Okay, so let's go ahead and simplify first. So on the left-hand side, I'm going to bring down my 3x. I'm going to distribute the -1, so -1 times 5x is -5x. -1 to the -4. -1 times -4 is positive 4 equals, on the right-hand side, I have -8x plus, instead of writing 2 squared, I'm going to go ahead and write 4 minus 2x. And then our second step is that we're going to combine like terms on either side of the equal sign. So on the left side, I have 3x minus 5x, which is -2x. So this is -2x plus 4 equals, on the right-hand side, I have -8x minus 2x. So -8 and -2 is -10x plus 4. Then I'm going to go ahead and move all of my variables to the left-hand side. So I'm going to get this -10x off of the right side by adding 10x to both sides. Okay. And then -2x plus 10x is 8x, so this is 8x plus 4 equals 4. I'm going to move all of my variables, move all of my constants to the right. So I'm going to subtract this 4 off the left-hand side. And so I end up with 8x equals, now 4 minus 4 is 0. And then last but not least, I'm going to solve. So to solve for x, I need to divide by 8. To undo that 8. And so 0 divided by 8 is 0. So x equals 0 is my final answer. Again, we could substitute that back into the original equation to see if we got it right. Okay, and we are going to move on to our level 2, or well, really our level 3 questions, I would say. We're kind of, these are all at least level 2 questions. None of these are really easy. So 3 and 4 are a little bit different because they end up being one of those special case scenarios. Okay, so we're going to get to the end and something interesting is going to happen. And we're going to kind of talk about, well, what does that mean? And it'll help you figure out how you want to answer the question. Okay, so just like the other problems, we're going to start by distributing on either side. So this is 3 plus 4 times the 2 is 8. 4 times the negative x is negative 4x. Equals negative 2 times 2x is negative 4x. Negative 2 times positive 3 is negative 6. Plus 17. Collect like terms. 3 plus 8 is 11. So this is 11 minus 4x equals negative 4x. Negative 6 plus 17 is positive 11. Okay, and I'm noticing that I have 11 minus 4x and negative 4x plus 11, and it looks like they're the same on both sides. I'm going to keep going just in case you don't recognize that right off the bat. So my next step is to move all of my variables to the left-hand side of the equation. So I'm going to add 4x to both sides. And what happens is on the left-hand side I get 11. Negative 4x plus 4x, they subtract out. So, and then on the right-hand side the same thing happens. And I get this really funny situation where there aren't any variables left because they all dropped out. So I have 11 equals 11. Now, the question is, when is this true? When does 11 equal 11? Will 11 equal 11 tomorrow? Yes. Does 11 equal 11 today? Yes. Will 11 equal 11 in the future? Yes. So the answer is that 11 always equals 11. And you should know that because otherwise we'd have no basis for math in general, okay? So 11 does equal 11 and it will always equal 11. So this has infinite solutions. Okay? And x can be any real number. So we say x equals all reals. Okay, because no matter what, 11 will always equal 11, so it doesn't matter what number I put in there, I'll always get a true statement. And you can try that out by actually substituting in any number. So let's pick a random number and put it back into problem number 3. I'm going to pick 1. So I have 3 plus 4 times 2 minus 1. So for x, I put 1. And I have to do the same thing on the right-hand side. Equals negative 2 times, instead of writing x, I'm going to write 1, plus 3, plus 17. Okay, order of operations says that I have to simplify inside the parentheses first. So this is 3 plus 4 times 2 minus 1 is 1, equals negative 2 times 1 is 2, plus 3 is 5. So this is negative 2 times 5 plus 17. And then on the left hand side, 3 plus 4 times 1. 4 times 1 is 4. So 3 plus 4 is 7. And then on the right hand side, negative 2 times 5 is negative 10 plus 17. Negative 10 plus 17 is 7. So I picked a random number, I picked 1. You could have picked any number and that still would have came out to be true. So any number for x actually would work for that problem. Okay, so when you get a true statement at the end, your answer will be all reals. Problem number 4 is actually the opposite of that. Okay, so we're going to get a false statement. Let's check it out. Actually, just kidding. Let's do 3 times 4 minus 3x. Equals 5 plus 6 times 7 minus x minus 3x. Alright, so we start by distributing. So 3 times 4 is 12. 3 times negative 3x is negative 9x equals 5 plus 6 times 7 is 42. 6 times negative x is negative 6x. Bring down the negative 3x. And then we're going to go ahead and we're going to collect like terms. So on the left-hand side, we don't have any like terms, so it's 12 minus 9x equals. On the right-hand side, we have 5 plus 42, which is 47. And negative 6x minus 3x is negative 9x. Okay, then we're going to move all of our variables to the left. So I'm going to add 9x to get it off the right side. And check that out. When I add 9x to the right, or when I add 9x to the left side, they subtract out. And so I have on the left side 12, on the right side 47. And so you ask yourself this question, there aren't any variables. And so I ask myself, when does 12 equal 47? Never, right? If someone told you you had $12, that would be very, very different than them telling you that you had $47. So in this case, x cannot be any number. So we actually don't say x equals because it can't be any number, so we just say no solution. Okay, you cannot plug in anything for x and get a true statement because 12 does not equal 47. Okay, that's all I have as far as notes go. So I'm going to give you guys 4 problems to check out and do on your own. And I'm going to actually give you the answers to them so you can check and see if you're right. Okay, so problem number 1 is 21 plus 6x equals 30 plus 7 times x minus 1. Problem number 2 is 4 times 3 plus 5y minus 4 equals 3 plus 2 times y minus 2. Problem number 3 is 8 times x minus 2 equals 5 times x plus 4. And problem number 4, let's do 2 times x plus 3 minus 3x equals 5 minus x plus 1. Okay, and you can take your time to solve those. And the answers are being posted right now. And when you're finished solving them, you can enjoy the rest of your weekend. Okay, so answers are posted. Work on those and enjoy your 3-day weekend. Night, guys.